this lesson, we begin the advanced section of Python programming. We are going to learn about object-oriented programming, commonly called OOP. This is one of the most important concepts in all of software development. Almost every major application you use, be it banking apps, social media platforms, hospital management systems, etc., they are all built using object-oriented programming. So, what is object-oriented programming? Let me explain it with something you already know. Think about a car. A car has certain properties. It has a color, a brand, a model, and a year. A car also has certain actions it can perform. For example, it can start, it can stop, it can accelerate, and it can brake. Now, imagine you are building software for a car dealership. That dealership has hundreds of cars. Each car has its own color, brand, model, and year. Each car can start, stop, accelerate, and brake. Without object-oriented programming, you would have to create separate variables for every property of every car. This would be hundreds of variables, and managing them would be a nightmare. With object-oriented programming, you create a blueprint for what a car looks like and what it can do. Then, from that blueprint, you can create as many cars as you need, each with its own specific color, brand, model, and year. That blueprint is called a class, and each car created from that blueprint is called an object, also known as an instance. This is the art of object-oriented programming. You define a class once, and from it you can create as many objects as you need. Let's open the terminal and go to our working directory. Let's create a new file. Let's name it oop.py. Switch to the insert mode. Let's define our first class. Press escape, then save. Let's run the file. You can see that it printed the details of both students correctly. Now, let me explain everything that happened step by step. Let's firstly talk about the class keyword. Class student, colon. This defines a new class called student. The class name starts with a capital letter. You can see that the word student, I made it to start with a capital letter S. This is the standard convention in Python. Class names always start with a capital letter. Everything indented under the class line belongs to the class. Now, let's talk about the init method. Before talking about the init method, you must first understand what a method is. A method is very similar to a function. In fact, a method is simply a function that belongs to a class. When a function is defined inside a class, we usually call it a method instead of a function. For example, earlier in this course, we created regular functions using the def keyword. But when we define a function inside a class, that function becomes a method of the class. So, whenever you hear the word method, think of it as a function that belongs to a class or an object. Now, inside this class, we have a special function called init. Notice that the word init has two underscores before and after. This function is called the constructor. It is a special method that Python calls automatically every time you create a new object from the class. Its job is to set up the object, to give it its initial properties. The parameters of init are self, name, age, and score. Self is always the first parameter of every method inside a class. It refers to the specific object that is being created or used. You do not pass a value for self when you create an object. Python handles that automatically, but you must always include it as the first parameter. Name, age, and score are the properties we want each student object to have. Inside the init method, we have self.name is equal to name, self.age is equal to age, self.score is equal to score. These lines store the values passed as permanent properties of the object. Self.name is equal to name means take the name value that was passed in and store it as a property of this specific object called name. Properties stored with safe dots are called attributes. They belong to the object and can be accessed from anywhere in the class or throughout the object itself. Here, the attributes are name, age, score. The attribute values are passed as arguments when an object of the class is created. For example, the first object we created is student1 is equal to student open bracket additional 26, 85. Here, additional 26 and 85 are the attribute values. Additional is the value assigned to the name attribute. 26 is the value assigned to the age attribute. 85 is the value assigned to the score value. The second object we created is student2 is equal to student open bracket Bola, 22, 72 close bracket. Here, Bola 22, and 72 are the attribute values for these objects. Bola is the value assigned to the name attribute. 22 is the value assigned to the age attribute. 72 is the value assigned to the score attribute. Notice that both objects have the same attributes, name, age, and score, but each object stores its own values for those attributes. Now, let's move to creating objects. Student1 is equal to student open bracket additional, 26, 58. This creates a new student object. Python calls the init method automatically, passing in additional 26 and 85 as the name, age, and score. Student2 is equal to student open bracket Bola, 22, 72, close bracket. This creates a second student object with different values. Both are created from the same class, that is, the same blueprint, but each one has its own separate data. To access an attribute of an object, you write the object name, then a dot, then the attribute name. For example, student1.name, student2.age, and so on, as we've used them inside the print function. Now, let's add methods to our class. As I've said earlier, a method is a function that belongs to a class. It defines the actions that an object can perform. Let's update the file. The print open bracket dash 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 close bracket is just to make a demarcation line between the first student and the second student, so that the result will show nicely when we run it. Press escape, then save. Let's run the file. You can see that each student introduced themselves with their own specific details and grade. Let me explain the new things in the code. Get grade open bracket self close bracket is a method. Notice that self is still the first parameter, just like in init method. Every method inside a class must have self as its first parameter. Inside getGrade method, we use self.score to access the score of the specific student object. Whichever student calls this method, self will pass to that student. Also, don't forget that methods are functions in a class. Introduce open bracket, self, close bracket, is another method. Inside it, we call self.getGrid method, which means call the getGrid method on this same object. A method can call another method of the same class using self dot. After creating a class object, you can call any method of the class on that object. To call a method on an object, you write the object name, then a dot, then the method name with brackets. For example, student1 dot introduce, open bracket, close bracket. Now let's look at something important. Each object has its own separate data. Let's create a new file named update.oop.py. Switch to insert mode and let's write the following codes. Press escape and save. Let's run the file. You can see that updating student 1's score did not affect student 2's score at all. That is because student 1 and student 2 are two completely separate objects. They each have their own copy of the data. Changing one does not affect the other. This is one of the most powerful things about object-oriented programming. That is, each object is independent. Now let's build a more complete class. Let's create a new file named complete.oop.py. Switch to insert mode, then let's write the following codes. Press escape, then save. Let's run the file. You can see a fully working BankAccount simulation. Account 1 starts with 50,000. We deposited 20,000. Then balance becomes 70,000. We withdrew 15,000. Then balance becomes 55,000. We tried to withdraw 200,000, but the balance was not enough. So it said insufficient funds. Account 2 is completely separate and it was not affected by anything we did to account 1. This is a real-world example of object-oriented programming. A bank account is a perfect object. It has properties like owner and balance, and it has actions like deposit, withdraw, and check balance. Now, let's build a final practice program for this lesson. Let's create a new file named studentmanager.py. Switch to insert mode. Let's write some codes. Press escape and save. Let's run the file. You can see a complete student management report. Each student with their scores, average, grade, and status, all generated from the same class but with their own individual data. Notice how clean this is. We created 4 student objects from the same student class, put them in a list, and looped through the list calling the display method on each one. The class handles all the logic. The main program just creates objects and calls methods. This is the beauty of object-oriented programming. Your code is organized, clean, and easy to manage. Now, let's push everything to the GitHub. Let's go and check GitHub. You can see that our new files have appeared in the repository.